Hi, welcome to Data Modeling Part 1. This is a video in a longer series, which is an introduction to SQL. Right now, SQL, as some of you may know, stands for Structured Query Language, and it is a language that's used for retrieving and putting data when it comes to relational databases. So when it comes to data, right, you have the users of data, then you have the designers and the programmers. In very simple words, the users, in case of, say, there is a university database or a school database, right? Now, there's lots of data that you can think of that's possibly included or stored in a database like that. So you need data about the students, data about the professors or the teachers, data about all the classes, the schedules, the grades, and much, much more than that, right? You still have payroll, you have salaries, there are many different things that you have to store. Now, usually when it comes to a situation like where there's a lot of data and someone's trying to build a database, you have a person or team that plays the role of the data designer or designers, right? Now, these are the people who study the data and decide, okay, here is how we can represent this data on paper so that everybody can have a look at it and decide whether it's correct, and we can actually build a database based on that. Now, the programmers are the ones who actually build the databases and maintain the databases. The end users are the ones who use the databases, like you and I, for instance. When we access Amazon's website, we're using Amazon's database, right? When you log into your school's database system and look at your grades, you're the user. You're one of the end users of that system. So data modeling, the process of actually taking a view of what data is out there and representing that on paper, right? That's known as data modeling. And the whole point of that whole process of data modeling is to reduce the complexity of the design of the database. Now, data models, it's important that they be relatively simple representations of complex real world data structures. And the reason why we want to make them relatively simple is so that people can look at it and see if it makes sense or not. Now, more often than not, these are graphical in nature. And more importantly, when someone's building a data model or they're going through the design process, it tends to be an iterative process because you build something, you show it to the people who either create the data or who plan to use the data, and you keep changing it and modifying it and improving it until you get a fairly good representation of the data that's out there. So it tends to be iterative and progressive. So the whole point of the data model is it facilitates a conversation between the designer of the data, the applications programmer, the one who builds the application. For instance, you have the front end, right? To Amazon, or you have the front end to university or school database that connects to the database and retrieves information from it and puts data in it, modifies data in it. Now, all that is created by the applications programmer. So the data models, they help to facilitate the conversation between the designers, the programmers, and also the end users. They have to be involved in the process too. Now, end users may have different views of the data and different needs for data. So, for instance, when it comes to your school database, the principal may have a different need that needs to be fulfilled by the data. The teachers may have a different need. The students may have different needs. The staff may have different needs. The parents may have different needs. So you have to take into account the needs of all these various end users and merge them into your data model. So the data model essentially accommodates for and organizes data for all the various users of the database. So here's a very simple example of a data model. Now, if you try to look a little closely, let's go right to the center of the data model, right? You see the word winery. And then over here, you see wine. And if you go here, you see region. If you look up here from wine, it goes to inventory, wine to item, item to orders. So we can kind of guess that this is a data model that has something to do with wine and wineries, right? So we're trying to store data about wineries, right? That's a good assumption. So, just to see how to make sense of something that may look complex to some of you, if you again go back to the rectangle that's right in the middle, it says winery, right? Now, if you're storing data about wineries, you have some very basic data about wineries that you need to start with, right? So, every winery has a name, a description, a phone number, a fax number, and maybe you want to give it a winery ID when you store it in your database, right? So now each winery produces or makes wine, and a wine, as you know, has its own attributes. You have the name, the type, the year, the description, the wine ID. Again, the wine ID may be something you may just create to make it simpler for your database programmers to access the wines that are being requested or inputted into the system, right? So here's just an overall very quick idea of what a simple data model may look like. Just focusing or zooming in a little closer, when you have a rectangle, it's what we call an entity. It's something about which you want to store data, right? So in a university system or a school system, the student is an entity. So you want to store data about a student, right? Now, data about an entity is an attribute. So in this case, the name of the student is an attribute. Okay, so here again, we have another entity, which is course, right? And student and course are related because students could be enrolled in courses. So this is what we call a relationship between two entities. So if we add a little bit more detail into this, we've added some more attributes for student, such as student ID, student first name, last name, major, and credits. And similarly for class, we've said class number, schedule, and room. And if you see, look closer, you'll see that even the relationship between the two, it has an attribute. And that makes sense because when a student, in this case, takes a class, the end result of it is a grade. And the grade is the result of the relationship between the two of them, right? Now, grade cannot be the attribute of just student because student takes many classes and gets many different grades. And again, grade cannot be the attribute of a class because a class is again taken by many students who get many different grades. Also, there are many different types of classes and which result in all kinds of grades for all kinds of students, right? So grade is the attribute that describes one specific relationship between a particular student and a particular class. Now, if we look at this, here I'm just going to show you a little bit more detail before I end part one. So the first one up here, you see employee and course. And now you should be able to recognize what attributes are, the ones in ovals. The thing I want to point your attention to is this N and N. Now, what that means is that one employee or each employee can take many courses, and one course can be taken by many employees. This is what we call a many to many relationship. And we're representing that by throwing in an N on both sides, right? Now we can make this a little bit here. If you come below, here we see we have employee and we have course, right? So in this case, we have a certificate right in the middle. So we see employee, one employee can earn many certificates. Each certificate is earned by a particular employee. Also, one course can result in many certificates being issued. Each certificate, again, is related to exactly one course. And this is where we're going to stop today.